Good evening. Good evening, everyone, and thank you for being here. My name is Abdelovaheb. I am joined today by my colleagues Ahmed and Youcef. We are here to present our research paper titled A Review of a Containerization and Virtual Machine Security and Efficiency Comparison. I would like to explain why we have chosen this topic. Before we dive into a technical details, I want to explain why we have chosen this topic. As a computer science student, we spend a lot of time writing code, but we realized that writing the code is only half of battle. The other half is running that code efficiently and securely in the real world. We noticed a massive shift in software industry. For a long time, virtual machines were the standard. If you wanted to run an app, you launched a heavy VM. But recently, we have seen the explosion of tools like Docker and Kubernetes. It seemed like everyone was moving toward containers. This led us to critical questions, which became the foundation of our research. Are we sacrificing security for the sake of speed? We wanted to understand if this new trend of containerization is actually safe enough to replace virtual machines, or if we still need the strong isolation of the old way. This topic is deeply connected to what we study in operating systems. Concepts like kernel management, process isolation, and resource allocation. We wanted to see how those theoretical concepts apply to the modern cloud and DevOps tools used by companies like Google and Amazon today. So let's get started by the introduction. Virtualization is the backbone of modern cloud computing. In the past, running one application on one server was a waste of resources. Today, we use virtualization to run multiple systems on a single physical computer. Our paper explores the two main ways to do this: virtual machines, which offer strong isolation, and containers, which are lightweight and designed for modern DevOps. Our goal is to clarify differences so developers can choose the right tool for the job. Let's look at the core concept. A virtual machine, or VM, acts like a full physical computer with its own CPU and memory. Usually, every VM runs its own full guest operating system and sits on the top of hypervisor. In contrast, containers are a new technology made popular by Docker. Instead of a full OS, they share the host's kernel. They use features like namespaces to isolate processes, making them much lighter than VMs.
Now, let's look at the architecture. Starting with the figure 1, this diagram illustrates how virtual machines are structured. At the bottom, we have the host hardware. Sitting directly on top is the hypervisor. You can see that for every app, app 1, app 2, and app 3, there is a complete guest OS block. So for the explanation, this is the most important takeaway for VMS, because every single application requires a full operating system to run. There is a significant redundancy. If you run 10 VMS, you are running 10 kernels, which consume a massive amount of memory and storage. In contrast, here is the figure 2, showing container architecture. We still have the hardware and the operating system at the bottom. However, look at the difference. We have a container engine like Docker instead of a hypervisor. The explanation of that is we can notice that the app sits on top without their own guest OS. They all share the same kernel. This architecture explains why containers are so efficient. They only package the application and its specific libraries, removing the heavy weight of the operating system. Runtime and orchestration. To manage this, we use container runtime, like Docker, to start and stop these containers. However, in large companies, we don't manage them manually. We use orchestration tools like Kubernetes. These tools automate the deployment, scaling, and networking of containers, ensuring that if a service crashes, it's automatically restarted.
Thank you, Ahmed. Now let's compare security. VMS are generally more secure because the hypervisor provides a hard boundary. Escaping a VM to attack the host is very difficult. Containers, however, are considered to have weaker isolation because they share the kernel. If a hacker exploits a vulnerability in the kernel, they could potentially access all the container on that machine. We mitigate this using tools like Linux and by scanning images for vulnerabilities. Efficiency. When it comes to efficiency, containers are the clear winner. Startup. A container starts in a millisecond because it is just a process. A VM takes minutes to boot up. Performance. Our research shows that for CPU and memory tasks, containers have almost zero overhead compared to running natively. So as you can see in this table, it summarizes our findings. If you need mixed operation systems, like Windows and Linux on one server, you must use VMS. If you need scalable web apps or microservices, containers are the standard choice. Now looking ahead, the line between these two is blurring. We are seeing the rise of micro-VMS like AWS Firecrackers. These try to give us the best of both worlds, the security of a VM with the speed of a container. Most industries today use a hybrid approach. They run containers inside virtual machines to get both security and manageability. In conclusion, there is no single winner. VMS offers strong isolation, while containers offer speed and agility. For system designers, the best strategy is often to combine them, using VMS as the secure of the infrastructure, and containers for application deployment. Thank you very much for listening and have a good day.